Hello, everybody, and welcome to today's interest session. These are brought to you by the ETIC at New York Tech, and it's our remote engagement sessions in technology is what we call the program, and they're sessions that I give to students that are technology-based and demonstration-based, and we kind of teach you how to get engaged with the technology if you haven't done much with it. But they're also geared around technologies that have many jobs available. If you're not exposed to some of these technologies that we provide to you in the interest program, viewing the videos, getting practice with the technologies will give you kind of a benefit and an advantage when you're looking for jobs once you graduate. Okay, and even before you graduate, looking for internships. These are technologies that are in demand and in use at many organizations. That's why we give sessions in Java, but we also give sessions in Python and SQL Server and Visual Studio and C#. These are all applications and technologies that are in use in a number of different ways at many organizations. Okay, so today is in Java. Java has been around for a long time. Many different versions of Java, and always kind of expanding and growing in abilities. And the thing about Java is that it is a technology that is able to be used in multiple platforms. It's platform independent, which means that if you want to run it on Unix, on Linux, on Windows, Windows Server, on Mac, you can run Java applications. I believe the iOS, the iPhone app is the only one that does not run it, but that could be, somebody could correct me if that has changed. But essentially, when you build a Java application, for the most part, every device and every platform can use it without really changing it at all sometimes, and sometimes not that much. To compare that with something that you may not understand why that's so important, if I wanted to build an application for Mac users and PC users, I have to build it two different times if I don't use Java. If I use Windows, I got to build it in C#. If I use Mac, I have to build it in Objective-C, and to have this ability to build it once is very attractive. You'll also see something called JavaScript, and it's the Java language, but in a scripting mode. So when we deal with cloud-based systems and browser-based systems where we don't really want to have any install it at all on the machines, we just want to have it run through the browser or the phone or the tablet or the workstation, we have to build it in a scripting kind of format. So it's run at the server side, and it makes the changes in the local machines. So so those are the reasons that Java is so powerful. The other piece is that there's different versions of the Java virtual machine, JVM. Java virtual machine run is what allows every machine, every device in the world to run Java applications. But what it means is that having a Java virtual machine that will run any Java application that you create on any platform, there are core virtual machines that will run that you can run on embedded systems. So you can take a small chip-based system that you're developing, and the code that you develop in Java will run on that system. The code that you're developing for the big Windows Server application will run on that system. So the coding, the syntax, everything else, the way you create the programs don't really change much, but it runs on such a wide variety of devices that has such control over so many different input-output type devices that it's extremely popular and very powerful, okay? It's hard to compare with other languages because things like Python doesn't really compile. You need the Python program to run it. Java runs on the JVM, the Java Virtual Machine, and that is essentially delivered really standard on every device in the world, the way they work the licensing with it. So it's very important to understand those components of Java. So that's kind of the introduction to the program. The ETIC, just so you know, these are provided by the Entrepreneurship and Technology Innovation Center, where I'm the director. And we do have sites in both of our campuses now. We have room 107, Harry Shore Hall in Old Westbury, and we have room 607 and 608 are the ETIC in the New York City campus at 1855 Broadway. Those of you who are unfamiliar with the ETIC, we run a number of different programs here. Interest is one of them, but we're also a prototyping center. We're also the senior design labs for College of Engineering. So if you have an idea for a new business or a new idea for a new product, we work with you on those, but we also build first run prototypes of technologies for outside companies. So recently we built a number of different prototypes for companies, but we also secured a contract with NASA. So NASA is giving us patents that they want prototypes built for. And that's one of the ways that our students get firsthand experiential learning and get paid for it through the ETIC working on these prototypes. Okay, so if you've never visited the lab, please stop by. It's a very cool place to kind of hang out and be. And we also have a ton of technology here for you to use if you want to get your hands dirty. But on the same note, Once we take that location and we fill it with students working in different competitions and labs and projects and all that, it's a very exciting place to be and to work with. And it's here for you at New York Tech. All right, so let's get into our demo with Java. And the way I'm going to kind of work this is talk about a little bit about the career opportunities that you have. If you take a look on Indeed, just kind of browse around like I did even in preparation for this program, you'll see a lot of senior developer positions in all these different languages. Keep in mind, senior developer doesn't mean, you know, a guy my age or somebody's doing this 20 years, right? It means 3 to 5 years experience. So once you hit that 3-year mark, if you get a year working in school on projects, then you get 2 years as an intro developer, you know, and like as a new hire, you have your 3-year experience level, and that's what's going to consider you to be a senior Java developer. All right. So don't be scared of these titles, you know, senior, I don't have the experience. Take a shot. You know, there's really exciting. I'm jealous because I came out in a recession, but you know, when I graduated college years ago, but you're coming out into this post-COVID, you know, hiring boom that everyone's looking for people, and kind of people are naming their price and all that. So you have a really good shot at getting these positions once you get a few years experience, right? So just keep that in mind. Very good, lucrative career being a Java developer. A few overview topics to talk about before we show some of the coding of this. There's something we call the C family of languages. The reason we do that is that the way we structure the syntax and the way it compiles and the way it operates and the way we structure the object in object-oriented coding, we structure the objects in a certain way so that they communicate with each other. The way we do that in the C family of languages is extremely similar. And the reason we call it a family and we want to know about the family is because once you learn one, it's not terribly difficult to learn the other. There's tons of differences between them, but the overall syntax and the way things are structured is pretty similar. All right. So in those you have, you know, C, C++, Java, JavaScript, and C#, these constructs that we use here. One will help you learn the other. So don't be afraid to explore and expound on different objects. One of the things you want to take a look at here, you know, out of the top 3 languages, Java and JavaScript are 2 of the top languages. Keep that in mind as you kind of move through this topic as a career discussion. So let's just talk real quick about tiers. When we build applications, we build them in tier 1, 2, or 3, you know, constructs. And a tier 1 application is when the data and the application itself are all on the same device. Pretty much, we're kind of like a phone app or a PC, a workstation piece of software to connect to a printer or something like that. That software, really everything is on that one device. When we talk about 2-tier system, a client server system, we're talking about the application being on the device and the data being somewhere else and then on the intranet, on the local network inside your building. And then when we talk about tier 3, we're removing kind of everything off the workstation. We're working in a cloud-based environment. The application layer, the data layer, and the presentation layer of the application are all on the same system. We could say pretty much, not the same machine, but the same system. And all you need to talk to that system is some sort of browser, right? So from your phone, from your tablet, from your PC, from your Mac, from your Android device. As long as you have a browser, that software will work the same way. And that's really what a lot of developers are looking for today. And that goes back to, you know, web-based development, which is, again, Java, JavaScript, and C# and things like that. All right, so just understand that there's different pieces of software and there's reasons for building them one way versus the other, okay? Again, just to kind of a reference to the different tiers that you have to be aware when you're programming. All right, so we'll transition into the demo. What we're going to do on this demo, we're going to cover a couple of different things. We're going to talk about IDEs, integrated development environments. We talk about why they exist. We're going to talk about building packages, classes, and methods and the differences between them. We're going to talk about variables, conditionals, and loops that we use in all languages, but specifically in Java, we can see those in action. There's ways that you program in Java that you call methods, various methods from within the same class. You call methods from another class, and you send data from one class into another and receive data back from that class after it processes it. We have these things called data structures. We have stacks and queues and linked lists and binary trees and such that we use programming as well, right? And Java has its own flavors of these things. So what I'm going to do is I'm going to use this kind of as my reference list to go back and forth during the demo. I'll take a little bit of a pause in between each section and just make sure you see all of it. All right. The one thing that I just want to hit on before we do make that transition is just to remember we're working in object-oriented programming, OOP. And when you deal with objects, objects have names, they have attributes, they have behaviors. And once you do what we call instantiate an object, once you place an object in memory, that object is there for you. You can go all different types of code, all different parts of your code and all different parts of your classes, but that object stays in memory and stays populated with whatever you want it to have active. Once it's populated in memory, you can talk to it from other objects, right? So whether object-oriented programming was really something you understood beforehand or not, that's that's really not what this seminar is about. But just keep in mind that in Java, it's OOP, object-oriented programming, and we create objects so that we have a name to the object, a behavior object, what it does for you, how it behaves, and we have a way to communicate with that object from our various code in our classes. All right. Okay, so let's take a transition here and I'll move into our demo. All programming languages today have some sort of what we call an IDE, an integrated development environment, all right? So in this case, I'm using an IDE called NetBeans. That's a Java IDE, but there is Eclipse. Eclipse is another company that makes an IDE. BlueJ makes an IDE. IntelliJ makes a Java IDE. You can pick and choose whichever IDE you want to work in, but there's a couple of things you should know about IDEs. Employers want you to know how to work in an agile, A-G-I-L-E environment, okay? So an agile environment means that you are working in a SDLC environment, software development lifecycle environment, where you're taking the design of your system and you're working all the way through the delivery and maintenance of your system. But in agile, it's not a step-by-step process. With Agile, it's working with the customer along the entire way. It's working with another programmer along the entire project, right? So companies, when they hire you, they want you to be able to do what we're going to do today, but on the same note, they want you to understand how to work with another programmer, how to work with a customer, how to share information, how to document code. They want you to be aware that you want to move up and out career-wise, right? But on the same note, the company wants to make sure that you understand that you're going to create a value for them as an employee by creating projects and code that's well documented, that other coders know how to read and know how to update. That frees the company up to promote you. It also frees you up to leave for another job, and the company is going to maintain its value. And the company wants to see that about you. So when you're interviewing and you're talking to people about these jobs and all that, what you could do on a technical level, make sure they also know that I love to work with IDEs, because part of Agile is working with tools. How do you work with tools to share this information, version control tools, things like that? All right. So IDEs are really important that you make your potential employees aware that you know how to work with IDEs, you know how to use the tools in the IDEs, you know how to update your code and document your code and how to share your code and collaborate with other programmers so they can write their piece of the code, you can write your piece of the code, you can merge them together at later dates, right? So these are all important things that IDEs allow you to do in a bunch of different ways. All right, so NetBeans is the IDE that we will kind of use for this seminar. One of the things I'm going to show you is I'm going to show you a couple of different sample code that we have, but let's start with some basic things about Java, okay? Java, when you create a new Java project, the new Java project allows you to choose from a whole bunch of different types of Java code. Okay. Inside the IDE, you can create different projects that do different things. HTML5 is a new interactive type of HTML. You can create that inside of the IDE. But Java, JavaFX, Java Web, Java EE are different versions of Java that do different things inside of the IDE. Okay, we're going to stick with a basic Java project today, and you're going to create a Java application. And what you'll see as you go through that, you're naming the Java application a certain way, and you're kind of creating different things in the Java application that are going to stay with the Java application throughout. Now, once you create a Java application, we're going to use this one as our demo. But once you create a Java application, all the information that is part of that, it's stored in one folder on your PC. So when we actually look at where the actual information is kept, if we go to properties, right, we're going to see that this entire project is kept on a certain folder. So even though we see it in the IDE as a project name and we're able to interact with all the objects in there, it's really, in a very physical manner, it's really a folder on our desktop, right? So if I were to take this project, copy it and email it to somebody and they opened it up in Eclipse, they could look at that code and run the project just like I could, okay? So there's all kinds of ways that you can create these projects, but just know that they're really physical locations on your hard drive. So, and again, just to summarize that piece, IDEs allow you to see data visually, and allow you to see things in the way we're looking at them now and break them out. But really what it's doing is it's just showing you different ways and easier ways to visualize data that's really stored on your machine, okay, in certain locations. So we deal with projects in Java. We deal with packages in Java. Packages are different packages, little subsections of the project. Okay, if I wanted to create a very simple program, which we do here just to demonstrate how to send data back and forth between classes and methods and things like that, we just really need one package. But if I was building a bigger project where I have 3 or 4 different departments, I have purchasing and warehousing and finance and accounting, then I need different packages to separate the accounting classes, the finance classes, so you can create different packages. When you create different packages and you create classes inside those packages, each class can be named the same thing as the other because they're in different packages. So it makes it easier on the naming convention. This is the interest calculation class. This is the tax calculation class, but it's the tax calculation class of the finance package, it's the tax calculation class of the accounting package. So it makes it easier for us to manage our project by creating packages. Then we always have some class. In this case, the class is actually called main, but it doesn't have to be. But there's always some class in each Java project that has some notation of where the program needs to start. Okay, we call it a main method. There's only one main method in each Java project, and that main method resides in some sort of a class. And once that main method exists, the program knows when you first start it, knows where to start. Okay, and it's indicated here in the IDE by that little green arrow. Okay, that little green arrow tells you that the program is going to start here because there's a main method inside that class. All right, so what do I mean when I mean methods? When you open up any class, by the way, when you create a class, you go to File, you can go to New File, and inside that file, you can create a Java class. Okay, these are all the different things you can create with Java, different types of files. Java class is by far the most common, but we can create these things called interfaces. When you create an interface, what you're doing is you're saying to the rest of the world, I want you to use my program. My program is fantastic. It kind of solves world hunger and does the whole thing, but I don't want you in my program changing it and breaking it or kind of doing stuff to it. So I'm going to let you use my program, but I'm going to give you an interface to talk to my program, right? So many times in development work, we create interfaces so that we provide the benefits and the values of really great software that we've created without providing everything from the secrets of the software functionality. There might be some trade secrets involved in there, but we also stop people from actually going into the code to make it work. We simply give them an interface that they can send all the values that they need the program to look at, right? Product value, sum total, things like that. And then an example of the tax calculation, the interface connects to the tax program, processes things the way you want it to with the information you fed it, but then gives you back a result that's programmed to give you back, okay? And an interface will do that so that you basically have a user end of things, you have an interface, and then you have the real program here. So with the real program that calculates tax for 50 states accurately by county and is very complex, the program for tax calculation is over here, untouchable. The interface sits here, and then the user talks to the interface, calls the interface calls the program gives back the results of the interface, and the interface sends it to the user. And it's a great way to create really complex programs without really worrying about security or about having anybody on the outside actually ever touch the program. The interface is what they're touching, and the interface is programmed to do the middle work. It's very similar if you've ever worked with web services. If you created a web service that sits in a cloud-based server, you talk to the web service goes and gets you the data and sends it back to the website, but the web server, the browser is never talking directly to the website. It's a very secure and efficient way of doing things in a protected manner. Okay. So you have different ways of creating different classes in Java that will do different things. Let's talk about a class, right? Whenever we want to create a particular function of a program, meaning we want the program to calculate tax, to calculate interest, to calculate APR, annual percentage rate, or calculate amortization for a mortgage, okay? We don't want to throw those all into one area because it becomes what we call spaghetti code, where it's just all over the place and one thing leads to another and it's hard to read. All right, the benefits of quality code is when you actually have code organized enough that a programmer can go in and very easily solve a problem when there's a bug, very easily make an enhancement when there's a request, very easily remove some functionality that we don't need anymore. If it's difficult, you're paying all that money for the high-end developer to just search around how to do something, right? It's not efficient, it's not cost-effective, and nobody wants to see that you think that way as a potential employee. So you want to be able to structure yourself in a manner where if what you're being asked to do is truly original and unique, you're going to create a new class. And that class is going to have a very specific function to it. And if that class needs to talk to other objects, you may create multiple objects in the same class, but you may create a separate class with those objects as well. All right. Any way you slice it, a Java project can have many, many classes, and each method inside those classes can talk to each other. Okay. So let's take a look at method. I just mentioned that. Now let's see what that means. All right. Well, inside the Java project, we have a Java package. Inside the Java package, we have Java classes. Well, inside of a Java class, we have methods. And every time that we create a method, it becomes part of the class. And inside that method, we work with objects. Okay, that's the kind of hierarchical discussion of Java as a language, right? Now, in this case, we have a method. This method is called internal method. It's static void, all right? And that's the format of it. And in this method, we have a static void main method. The main method, as long as it's named main, is what Java looks for when it starts the program. Okay, so there's a whole bunch of different classes. It looks for a class with the main method and considers it the starting point for the program. It has to be named main. This is how it does it. All right. Now, if you notice, we have things called public static void main. All right. Public means that all the other classes can have access and see this method and use it, right? So if it's a tax calculation method, a whole bunch of different classes might have to use that for some reason. So you want to make it public. If it's just something you're going to run inside of the class, you just have to make it static void, okay? Void means it's not going to get any different information back from the user. It's not expecting it. It'll just run as it is. It doesn't need information to run. It'll just run, right? So if you have a printout module, it's just going to run. If you have something that says, look, I'm going to take 16 numbers and add them together and divide by 16, it needs those 16 numbers. So you wouldn't do it as void, you would do it as an integer or a double or some other value, okay? But identifying the methods in Java is how you identify what the method is going to look for to run properly, right? Is it going to look for a string value that you pass it, a series of string values that you pass it? Is it going to look for an integer value you pass it? What are you going to pass it that the system is going to say, I've got these 6 values that it just gave me, now I'm going to do something with them, right? You have to tell the system, you have to tell the class that this particular method is looking for something to process properly or not, okay? And that's what these are. So in this case, the difference is that one is private, meaning it's just going to run as an internal method inside the class. We don't need anybody else to know about this one. This is public, meaning that all the other classes are going to be able to run it, and even all the other packages. So even if we have multiple packages, they can still run it calling package name and the class name. So what happens here is that inside of a method, we have code, and that code is going to do different things, all right? So here we're going to run some basic examples of how to basically interact with other methods inside of our application, okay? So the first thing is that anytime that we have multiple methods, right? Method 1 and method 2, right? Anytime we have multiple methods inside of our application, they need to talk to each other, maybe, right? They don't automatically run. It's just that you create a method and it does something specific. It prints something out, it looks something up, it calculates something and gives you a value back. It calculates something and doesn't give you value back. It exports a text file. It does something, but it doesn't automatically do it until you tell it to do it. The way you tell a method to run inside of a class is by calling the method, just typing the name of the method with its parameters, the 2 parentheses, and then whatever that method is looking for, all right? In the case of internal method, we're not asking it to do anything but run whatever it's told to do. What is it told to do? It's told to system.out.println, right, output this text. Okay, notice how every time you have a line that you want it to function and stop, you have to have a semicolon. Okay, as you start typing in information, it will help you with the right, with the coding. So inside your IDE, this isn't Java, this is the IDE. The IDE helps you in a certain way to figure out kind of what's wrong. So if we are typing and we are, creating this, right, creating this same line, as we're moving, it's giving us the parameters so that we can say, we can make it do what we want to do, okay? So every time you use an IDE is reasons that you use an IDE. It's to make you an efficient developer. It's to make you work with other coders in a more efficient manner, right? Companies don't want to pay you for you to learn. They want to pay you to build software to deliver that company to their customers so that they can charge 10 times as much, right? That's what you're getting hired to do. If you're deciding to not use tools and not use an agile environment, you're not of value to the company. The value to the company is that you're willing to share your knowledge with another program. You're willing to develop using tools to create shortcuts. Okay, you need to think this way because this is what the employers are looking for. Okay, so basically we're creating a internal method here that's going to run, is going to output. In this case, we're going to do two different things now. So one is to output, this is how to call a method. Another one is I just added the word hello, so it's going to print twice. Now, if I made a mistake here, it not only would it tell me what the mistake is, and it could tell me actually really what's happening here. It's telling me that I couldn't find this particular symbol. It'll also underline it red. So I know that I have a bug. It also won't run. It'll just tell me that it won't run. So it won't compile. All right. So it's going to use the main method first. And the main method is very first line it calls is internal method with no parameters. So when I run this program, it spits out, this is how to call a method and hello, the first two lines. Now, whenever I want to basically kind of remark out some code and I don't want it to run, if I didn't want this to run, I just put 2 slashes in front of it. This is the way I comment my code. And if I didn't want any of these to run, I can basically just comment them out, right? And what will happen is that you'll start to see that the only thing that should run right now is internal method. So I won't get this output anymore. I'm going to get only, right, this is how to calculate a method and hello. Yeah, there's one more thing running here. So yeah, so now it's only these 2 items. That's all I'm asking it to run. Now, if we were really in a work environment, what we would do is we would basically say, we would use this feature. We would use /* and then, this is how I document my code for my coworkers, okay? And what you could do is you could now, because we use that /*, we could use all of these things to just kind of code our notes for our programmers, and then we can kind of do that, okay? And now we have this coding here that's going to tell our programmers, our coworkers, this is what I did with this. This is how I did it. If you need to edit it later on, say my project is taken over by you later on because I got a promotion and you got a promotion. You're not going to have to go grab me to figure out this code, right? You're going to be able to read my instructions and do that. That's what employers want to see. They want to see that you know that now, and you can show that now, and you can demo that now. If you show sample code to them, make sure you have it documented so they can say, oh, look, this student, this candidate knows how to document their code so that we will benefit more from it as an organization. Okay. So yeah, so this first thing is basically saying that the main method is calling the internal method and telling it to run. And this is what it does, right? Very straightforward. Now what we can do is we can kind of remark that out, and we can take this out and we can run this one. We want to now, the next step is to call an external class inside the same project, but outside of this class that we're working in. That was just calling a method inside the class. Now we want to call a method from another class. So if you look, this is external class dot external method, right? So there is a method just like these two inside of another class that does a very specific task, and we want to benefit from that in our program. So if we open up external class, which is another class part of this project, we'll see that there's a method called external method, and its function is to call an external method, is to print out, this is how to call an external method. So if we look at this from from the Java perspective here, when I run the main method, it's the same class it's starting up on. It's the same main method that was calling the first thing, first thing it wanted to do. But now it's running code from a completely different class. So if I wanted to run my interest calculation, my tax calculation, my amortization calculation, I can create, just get your head in order to think from a hierarchy perspective and break things out as small as you can make them. If you feel that you're going to build a project and there's going to be, like, think about a TV remote control, and you think that there's going to be something that you're going to do when they press 1, something they're going to do when they press 2, something that's going to happen when they press 3, something's going to happen when they press input, something that's going to happen when they press source, right? Think about the TV remote control, those buttons on it. Every button would be a different method, right? Every button might be a different class. Like, you might have a numbers class that just does numbers 0 through 9, right? But you're going to have an input class to change the input on the TV, right? So start thinking that whenever you're taking on a big project, whenever you're thinking about a big project, especially for Java, just in general, this is a good thing to do, but just in Java, start thinking about how you're going to break it down to tiny little projects. And every time you finish one, that project will be able to talk to the other projects, right? How do you do that? You break them down to classes. And inside each class, you break them even further into methods. Okay. And if you start thinking this way, it'll not only help you in Java and programming in general, it'll help you in life, because you'll start taking big problems and breaking them down to little smaller problems that can actually work together and talk to each other. All right. So this is an example of how to call another method from an external class. Okay. Sometimes we want to actually call a method that actually does some sort of mathematical work. Okay. In this particular method inside of this particular class, we're looking at how we work with numbers, okay? Anytime you work with Java and you work with numbers, you're gonna work with things like integer. I think I have to make that things like integer, things like double, things like string, okay? All these different pieces that we're going to work with, those keywords become ways for the system and the compiler to realize that you're looking to set this variable called test equal to a double value, meaning I can have decimal points and things like that. Okay. What it does is it looks at your code and says, this is not used. It's not wrong. It's not a bug. It's not going to crash, but you're declaring it here and you're not using it somewhere else in the program. Okay. So as you type in things into Java, you're going to start getting messages to tell you that you're not exactly bugs, but even things like that, you're not using them just to keep your code more efficient. All right. But here's an example that we're just basically showing, in this example that you have the ability to do an enormously complex level of mathematical features and functions, right? Whatever you want to do mathematically in Java, the ability is there to do that, okay? And in this case, for the interest calculation, all we're doing in this case, notice there's 2 brackets without any input. We're not asking any variables in here yet. We're just running it. So when we call interest calc, it's just going to run whatever it is we tell it to run. So when we take the remark comments away from calculate interest and we run that, okay, all it's doing is doing the calculation, outputting it, but it's not really calculating it based on what we give it yet. Okay, so let's look at that next. Sometimes what we want to do is we want to call a class. We want to call a class and a particular method inside that class, and then we want to give it data to process both numeric and string data, right? And what that class and method does with that data is not of concern right now. It's the fact that we can send a class and a method inside that class data for it to process. So it doesn't have to just run what we want it to run and then that's it. It can actually receive variables that it's going to run the same way every time, but it's going to run based on the data you give it, okay? And the way what we see with this one, well, actually, we're not going to see the output here, and I'll show you why in a second. But if we look up the parameter method in Java and we look up the parameter calc, look at what we're using. We are basically saying that in our parameter calc method, we're looking for 1, 2, 3, A, B, and C integers and a string. We're looking for 4 pieces of information to come in. 3 are integers, 1 is a string. If you notice, that's what we typed in before. So what I'm going to do here is I'm going to basically take out these comments because I think that's what's actually causing the issue. So we're going to output the total of A, B, and C here because they're integers. So it should work okay. And if I come back here to calculate interests, I'm sorry, the main, and I run the main method, okay, I now get the sum of the passed in parameters is 117, and the web page is open in the browser. So it's doing that second piece too. But if I change these values that I send in here, and I change this to 100, okay, it's no longer going to be 117, it's going to be 150. Okay, if I change this to 300, okay, it's now going to be 405. So my class and my method have not changed. I'm just changing the data that I put into it, right? So it's a neat way to create a class, keep your thoughts in order, create a method, keep your thoughts in order as far as what the class needs to do step by step, but then also to pass information that changes based on some other function that you're doing, right? It's information you're getting from the user, information you're reading from the web, information you're reading from a text file, all right? And then passing that to the method. And now the next step, now that we see that we can actually call a method and have that method process data that we give it, right? Before we ran a method and it just ran, next we ran a method, pass it information and process it. Now we want to basically say, process the data, but now give us back the result, right? That's the real value in the whole thing, right? Structure your data in these different classes and methods, and now send the methods inside those classes the values, have it do something with them. But then whatever the result is, return that to me. I want to see that result because I want to use that result somewhere else, right? So now what we'll do is we will look at the return method function here. And in the return method, what we're seeing is that now there's a method called return method inside the return method class, okay? And we're saying, okay, we are basically going to create a method, and we're going to basically say that we're looking for a double value called return amount. We named it return amount. And that value is going to look in, we're going to look into int, we're going to look into 2 integers and 2 doubles, all right? This particular method name, return amount, is looking for these values, okay? We're saying that this variable, a variable type of double, is equal to the sum of all 4 of these inputs that we're going to send in, okay? Here's the difference from before. Now what we're saying is that instead of static void, we're saying static double, all right? Why do we have to do that? Because we're deciding to send something back. We're deciding something back to the calling parameter. Whenever void means it's not going to send anything back. That's what void means. If we want a method to send something back to the calling parameter, we have to change that void to what we want. We could call it string, we could call it integer, we could call it anything we want. That's legitimate, but we tell it what we're going to send back. So this method now knows I'm allowed to send back to the calling method these parameters. So we're going to basically, with this keyword return, we're going to send back the variable total, which is equal now to the sum of these numbers. And to see this one kind of in action, we will now run this. Okay. Okay. So what we're doing here is we are running the return method, return amount method with these parameters, with these numbers. Then what we're doing is we are saying, let's set the double type variable of return of RET variable equal to these numbers. Okay. Here we're calling the return method, return amount in these numbers. And we're basically printing out this variable right here. If we wanted to basically remark this one out here, since we're kind of doubling the work, if you notice what's happening, we are outputting this return variable. We're printing it out. Here, we're setting the double return variable equal to whatever the return amount is of these numbers that we put in there. Okay, so if we put in 123, 345, and 122, and we ran this again, our total would be 635. And the reason that we know that is because we're outputting this. That's how it shows us the 635, but it's getting it because we're sending in 4 variables, 2 integers and 2 doubles, into that class, into that method. And that method is not a void type, it is a double type, which means it's instructed that it's permitted to send us back the returning value. All right. And this one line here and combined with this output line here is what makes this available, right? If you think about the power of this, think about designing a system that has to do a bunch of different complex mathematical calculations, right? You could create a class called math, and then inside that class, you could have method 1, 2, 3, 4, 5, and 6 that receive the values in that you need for area under a curve and regression analysis and all kinds of things that you would do. But whatever the result is, you're going to give that back to the calling method. So when you want to interact with those methods, as complex as they might be, this is all you're doing. In your main program where you're capturing information from the user, press 1 for this, press 2 for that. If you press 1 for this in a menu and then they type in 6 values, you can just send those 6 values to this more complex routine and give back the number, and you have a great calculation program for the user. So basically, in summary, we have the ability to call methods inside of classes, right? We know where the main method is as well. We need a main method to run the program. We have a way to call methods in a separate class, in a different class. We have a way to perform mathematical calculations that you saw. We have a way to call a method in a different class with parameters that are variables that are going to change each time, have that method inside that other class run those, and we now have a way to give back the result of that to our calling class, to our calling method inside the class. Java also has a way to interact with outside sources, right? In one case, we have the ability to interact with the internet. So we're able to look at resources on the internet and do things with them, okay? And the way we do that is we work with different packages and classes that we bring in as imports. And those classes allow us to interact with them and access these devices, these resources on the web. All right, so let me see if I can demonstrate that for you now, one more tool. Okay, so what I've done for this piece of the demo is I've reactivated, I've remarked everything else out, and I've reactivated the parameter method with these values. And if you notice, one of the things it says here is I am Ursula. Ursula is our eTIC research robot for student engagement and learning activities. That's where the name comes from. And it's our own homegrown robotics project. And we can interact with her over the web. And one of the ways we do that is through an API. In this case, we're using Java to talk to that API. And the question should be, how do we do that? And let me explain. If we bring up, I'll close out this one here, and I'll close out this one here. If we bring up the parameter method, what you're going to see is that in the beginning of the class, we name the package that we want to use, but we also import in java.net.uri. Java.net.uri is a class or a package in a class, combination of the both. That's pre-written. It's pre-established. It's accepted by Java as part of its core package. It's been, developed by a whole bunch of Java experts to interact with resources on the web. And by bringing that in, I'm allowed to do things like call a web page. I'm allowed to do things from within Java. In other words, if I don't have that package active, Java doesn't know what this is and it doesn't know how to do things. So by importing in that package, I'm able to interact with all the different things that package is programmed to do. All right, so what I'm going to do here is by activating that, what you'll see is that I'm telling the system to access this page and pass through data to that page. Anytime you see this question mark after a URL, it's passing through whatever data you have after that question mark into the system. All right, this is how Amazon works and Best Buy website works. And, anytime you deal with websites, you put a question mark, and then anything after that is what the website's going to read in and process. So in this case, we're calling our own Ursula web page and passing through information to it. And what you see is it's not terribly obvious, but it looks like we opened a web page, but we didn't. We ran a Java program. The Java program opened the web page. Okay. So we're able to utilize that information by creating Java applications that run website applications without behind the scenes, without loading a browser. They can run ASMX pages, which are web services. We could send data to a web service from Java. Incredibly powerful stuff. Once you start having these cloud-based web interfaces out there, and you're using JavaScripts that are very light and very super powerful, but very light on the computer, you have this great ability to really run these programs on local machines, but really interact with web-based sources. You can pull down stock data and weather data and spreadsheet data. Anytime you want to interact with web data, Java can do it, but you need to import in this web access package to do it, right? In this case, we're just calling a web page and we're inserting data into that web page and loading it. But you can also call a file and download it. You can download images from the web. You have all kinds of different ways to do that, interact with that. All right, so Java has that ability as well. The last thing that I just want to make sure you are aware of is that, so anytime that we are working with a Java application and we're making it do something, right? We're asking the user for things on input, we're processing things step 1, step 2, step 3. That's great, that's programming at its heart. But many times complex problems require multi-step processes with data that changes from step to step. Once that exists, if we don't have a little shelf to put our results from the first step on, and then go to the second step using those results, we're kind of stuck. It's really hard to do it in just a single program mode where we're kind of looping through different pieces using conditionals and if-then statements and things like that to process. If we don't have some way to process the first step, place that information in some sort of a holding facility, process the second step, place that information in a holding facility, take the first step and bring it down and process it. You can think about all these different shortest path problems that we use and stackable type problems that we have to do. We have to do each step at a time, but whatever the results of the first step are, we have to kind of temporarily store that. Once you start trying to solve complex problems like that, you need data structures. You need to store the results of whatever you came up with. It doesn't matter whether it's one result or 100 results. You need a way to store them in memory so that you can access that later on. Data structures is how we do that. Linked list is one data structure I'll give you as an example. But in Java, just like the URI import we did before, in this case, we're going to import in the java.util linked list package or class. And once we import that in, we're able to create these lists in memory, and we call them objects, right? And each object has a name. In this case, it's my list. My L list, we instantiate it as a new linked list. And when we work with data structures, we have constructors where we create them. This is a constructor. We have transformers where we transform them, we add and remove. And we have observers where we can look at the data without changing it, okay? And what you'll see is in this simple demonstration, we have the creation of a linked list, boom, pops it out there in memory. We name it. So the object has the name myList, and then we transform it. So once we're operating with a linked list, we're creating a linked list in this case called myList. That's the object name, and it's a new linked list. And we're using the constructor to create the list. We're using the transformer to transform the list. And what you'll see is that by doing myList.add, add is the transformer, we're adding whatever items that are in here. So when we output the list, the contents of the list, we're just seeing this list. These are actual data in memory in the object, right? Once it's out there in the ether, sitting out there for us, we can work in different classes and different methods. We can interact with each other, totally separate from anything else we're doing. That memory will still stay out there. You could have a linked list called My States, and there's 50 states in there that you can access at any time. You could have a linked list called My Music, and there could be 400,000 song titles in there. It doesn't matter what you use it for, but data structures, and especially data structures in Java for this seminar, are the way we take data in our programs and we temporarily store it so that we can access it from other programs later on, right? So when you're solving complex problems, you have a multi-step process usually. when you finish each step of the process, you're able to take those results and store them temporarily so that you can use those results to build upon the next steps of the problem, right? That's imperative in computer development and computer programming and software development. And data structures is usually how we do that, right? So with that, we're going to be at our stop time. I'm going to stop the recording now and open up for any questions. For those of you who hang on to talk, thank you for coming, and I hope you enjoyed the session, and I'll see you at our next one next week.